Hi everyone, I'm going to talk about the current divider. So how a current divider actually works. So you can get the clear understanding of a current divider. Have a look at this circuit diagram. In this circuit diagram, I is the current source. From I, it supplies I in the current, and this current is divided in two currents. One is I1, another is I2. And then I1 is passes from this resistor R1 and I2 is passes from this resistor R2. So that means this current IO in is divided with I1 and I2. So we are going to find the value for I1 and I2, and there is the point A. In this point, the voltage we denoted by V, and applying the Ohm's law for resistor R1 and R2, we can write V is equal to I in times Rp, where Rp is the parallel resistance for resistor R1 and R2. So Rp is equal to R1 times R2 divided by R1 plus R2. I put this equation 2. And again we apply the Ohm's law for resistor R1 and R2. Individually we can write I1 is equal to V divided by R1, because the voltage across this resistor is V and the resistance is R1. So I1 is equal to V divided by R1 according to the Ohm's law. I put this equation number 3. And for R2 we can get the value for I2 is equal to V divided by R2. I put this equation 4. So all these equations I just minimized in here, and then from equation 1, 2 and 3 we can write I1 is equal to I in Rp divided by R1. So we just replace the value for V with this value, which B is equal to I in times Rp from equation 1. So again we can write I1 is equal to I in times R1 R2 divided by R1 times R1 plus R2. We can cancel out this R1 and R2, and then we can write again I1 is equal to I in times R2 divided by R1 plus R2, which is the final equation for the current I1. So the same way from equation 1, 2 and equation 4, equation 1, 2 and equation 4, we can write I2 is equal to I in Rp divided by R2. We just replace the value for V, and for Rp, if we put the value for Rp, we can get this line here, which is I2 is equal to I in times R1 R2 divided by R2 times R1 plus R2. We can cancel out R2 and R2, and then we can get this final equation for I2, which is I2 is equal to I in times R1 divided by R1 plus R2. That's the final equation for I2. So let's have a look the example, then you can get more idea of how this current divider actually works and then the proof as well. So from this example we want to find the value for I1 and I2, and we say the current source supplies 50 milliampere of current, like I1 is equal to 50 milliampere, which is divided into two currents I1 and I2 with the resistor are 2.2 kilo ohm and 5 kilo ohm respectively. So using these equations we can get I1 and I2 very easily. For I1 we just put the value for I in, and for R2 is 5 kilo ohms, R1 plus R2. After calculation I found I1 is equal to 34.7222. I just put 72. So for I2 we just replace the value for R1, which is 2.2, and then after calculation we can get I2 is equal to 15.27 milliampere. And then altogether, which is amazing, that I in is equal to I1 plus I2. Just adding these two value we have found, and then the input current for R1 and R2 resistor, the both is like 50 milliampere, for which you can see the input current in this node was 50 milliampere. Then after adding these two current I1 and I2 also we found 50 milliampere. So that's how this current divider actually works, which is amazing. Thanks for watching. If you like this video, please subscribe my channel.